Okay. Section 9.3 is all about the quadratic formula. Our learning objective today is to use the quadratic formula to solve quadratic equations. Okay, now, if we're going to solve 2x squared plus 8 equals 106, that's what we did last night for homework, yes? Yes? Oh, all but Drew. Okay, so subtract the 8. We get 2x squared equals, that's going to be 98. Divide by 2, so x squared equals 49. Square root both sides. Little 2 knocks out the radical, and I'm left with what? Just 7? Plus or minus 7. Of course we have two answers because of the squared. Okay, so it's plus or minus 7 are our answers. Now, can we solve this equation using our square root method? No. So as of today, before today, how could we solve this equation? We could factor it, yes? X minus 4x plus 2 equals 0. So x is what? 4 and negative 2. Okay, what if it didn't factor? What if we could not factor it at all? We still has answers. It's got 2 answers. We know it has 2 answers. They might be imaginary. We might not be able to see them. Okay, but there are 2 answers. If we can't factor it to solve it, we need another way to solve a problem that can't be factored. And how we solve is by meeting Bob and Bill. Bob and Bill are going to help us figure this out. So we got Bob and Bill here, and they are the coolest dudes on the planet. They are super duper cool. They're brothers. They're way cool. They have a butler. They are rich, cool dudes. They have a brother, or a butler. They have a butler, and they live in a rad house. They live in an awesome house. They sit there and they live in the rad house. The butler takes care of them, and they live in the rad house, and it's the coolest place ever. Now, one day, you see, they're playing video games all day, and they got kind of bored at home, so they decided to go to the mall. So they go to the mall, and when they get to the mall, they're just kind of wandering around. They don't really have anything to buy. They don't need any cheap plastic crap for their rad house. But they're hanging out, and guess what they run into? Where's my thing? They run into 4 awesome chicks. They run in, and there's 2 twins there even, and they run into 4 awesome chicks. And you know those awesome chicks are walking around with 2 pet alligators. Very strange. However, they are awesome looking chicks. And so Bill and Bob, they're like, ooh la la. So they start hanging out with these 4 awesome chicks. And they said, hey, why don't you come back to the rad house? We'll play some video games. We'll get our butler to make us some hot chocolate, and we'll hang out. And they say, we'll have to bring our alligators. Guys, said we have to bring our alligators. They're our pets. And Bill and Bob go, that's okay. We're good. Let's do it. Let's go home. And so back to the rat house they go. However, the pet alligators were kind of driving Bill and Bob a little crazy. So they said, we need to put those alligators down in the basement because they're just a little creepy for me sitting up in the front room, you know, when we're all playing video games and such. So they're hanging out in the rat house. The butler comes and says, would everybody like some hot chocolate? And everybody says, absolutely. And the hot chocolate, he's bringing in the hot chocolate, and he trips over Bill's big feet there and goes flying. He spills the hot chocolate on the 4 awesome chicks. And they're like, ah, it burns, it's hot, I'm going to sue you. We're going to sue you. And they're like, Bill and Bob's just looking at them, what? And they said, we're going to sue you, we're going to take your house. So, Butler's cleaning up. I'm going back. I went back too far. The Butler's cleaning up. And he goes, because he cleans up, and he goes, I got to go get the carpet cleaner. He goes to the basement to get the carpet cleaner. He sees the 2 alligators, and he totally freaks out. And he runs out, and he goes, I don't get paid enough. I'm leaving the rat house. And so Bill and Bob now are without a butler. They may or may not have their rat house after the girls sue them. They definitely don't have the 4 awesome chicks. However, they still do have the 4 alligators in the basement. 2 alligators in the basement. Therefore, they're without the butler. Bill and Bob may or may not be without a house, but they are definitely without the 4 awesome chicks. And they have the 2 alligators in the basement. Nice. Right? Did you like my story? Definitely think. It just all came to me one night in a dream. Therefore, here is your quadratic formula. Here is your quadratic formula. You must know this quadratic formula. There is a song, and I can't play it because I'm recording, so I'll play it at the end. However, I will sing it now. Does that work? Yes? Because I can't take this out and you can hear, and so we'll just have to play. Okay. There are 100 ways to sing the quadratic formula for you to remember. If you did a search on YouTube for quadratic formula, you'll come up with a million zillion hits. All of high school kids like you singing the quadratic formula to just a ton of different songs. See what really cool high school kids do in their spare time? If you don't believe me, search. It's unbelievable. Tons of really cool high school kids out there taking this quadratic formula and singing it to just about anything you could even think of. Okay, now, I am not very musically inclined. So I kind of learned it one way, and I sang it that way for a couple of years. And then I learned another way. But I can't do it because the new way keeps reverting back to the old way. That's a problem I have. So I can't sing it more than one way, apparently. It's an issue I have, musically inclined. I'm not good. But I've heard it sing. I mean, like I said, if you YouTube it, there's 1,000 ways to sing it. And why do we sing something like this? To help you memorize it, of course, right? There is definitely a link there to music and memorization and so forth. So singing it helps you remember it. Am I going to give you this formula on your quiz or test? Absolutely not. You will need to know this formula by heart on the first day of Algebra 2 next year when you show up, after being gone all summer and not thinking about the quadratic formula for 3 months. Okay? When you get to Algebra 2, you'll be using the quadratic formula weekly throughout the entire school year. Then you'll move on to geometry, and guess what? You'll use the quadratic formula there. And then you'll move on to pre-calculus, and again, you'll be using the quadratic formula. I mean, it does not go away. Okay? And it is one that you need to know and need to memorize and get it. Okay? I mean, it's just one of those things that you're going to use it to solve other problems. It's not going to be the problem that you're solving anymore. Like right now, that's going to be our problem. We're going to use this and get an answer. as you get further on, that's just kind of a mode of showing some work to get to an answer, okay? So this is an important one. Anyway, I can sing it as, well, now I got this other one in my head. You can go to Pop Goes the Weasel. Negative B, let's see, pop goes the weasel, and around every bush hops the weasel. Negative B plus or minus the square root of B squared minus 4AC all over 2A. It's not the one I can always do, but here's the one I can always do. X equals negative B plus or minus radical B squared minus 4AC all over 2A. It works. You ready? It's karaoke. You have the words. Right? I can make it a ball. You ready? X equals negative B plus or minus radical B squared minus 4AC all over 2A. Right? All right, with me now. Karaoke style. Here we go. Music, memory goes together. Sing with me. If you're not singing, I'll make you sing by yourself. Are we ready? X equals negative B plus or minus radical B squared minus 4AC all over 2A. Okay? I mean, it's not the best, however, if you have time tonight and want to go home and Google the quadratic formula, if you find some really cool high school kids singing it to some really cool tunes, and it's school appropriate, and you think it's awesome, share it with me, and I'll show some in class next time. Okay? If I don't get any, we won't see any. I'm not going to sift through them all. Okay? So if you find one that looks good, send it to me, email it to me, write down the name so we can find it, and then we'll watch a few of them in class next time. Does that work? Okay. So let's use it. This was that first one, and we already kind of figured out, what was it, 4 and negative 2? We're going to use the quadratic formula on it this time. I know factoring is going to be definitely by far the easiest way to solve any of these. If it factors, factoring is the quickest. I can actually factor in my head and know that that's negative 4 and positive 2, therefore set them equal to 0 is going to be 4 and 2, negative 2. I can almost do that in my head, okay? Factoring is by far the easiest and fastest way to solve quadratic equations, if it can be factored, okay? If it's going to take you forever to figure out how to factor it, or if it can't be factored, then you have to go to the quadratic formula, okay, which is x equals negative b plus or minus radical b squared minus 4ac all over 2a. Okay, now, what is all this A, B, and C stuff? This is, Bill and Bob and the 4 awesome chicks and the 2 alligators. What do they mean? Well, I'll tell you. Your quadratic equations are always written in the form ax squared plus bx plus c equals 0. We always have to have it equal to 0, so if it's equal to anything else, you need to move it all over so that we get it all equal to 0. That means the number in front of the x squared is an a, the number in front of the x is a b, and the constant, which is the number that will never change, the constant is c. Okay? So in this situation here with this equation, what is a? 1, because there is a 1 in front of this x squared. What is b? Negative 2, and what is c? Negative 8. So A is 1, B is negative 2, and C is negative 8. Those are what our numbers are. We just plug them in. Plug it in. Negative B means the opposite of B. So what's negative 8? Positive 8. It's going to be the opposite of what it is. So we have 8 plus or minus. B squared, B is negative 8. Yes? Yes. Oh. Oh my. Okay. B. B is negative 2. Opposite negative 2 is positive 2. Thank you. Sorry. So I was the butler. I screwed up the butler. Called him by the wrong name. So we've got 2 plus or minus b squared, which is negative 2 squared, minus 4 times a, which is 1, times c, which is negative 8, all over 2 times a, which is 1. Now, yes, you're going to be able to do some of this stuff kind of in your head as you're working through it. I always do this squared term in my head. What is negative 2 squared? 4. Negative 4 times 1 times negative 8. A negative and a negative makes a positive, yes? And 4 times 8 is 32. All over 2. So now we have 2 plus or minus the square root of 36 underneath that radical. What is the square root of 36? 6. So we have 2 plus or minus 6 over 2. Now we can actually work this out. Remember, the plus or minus means we have to do 2. We have to do the plus version and we have to do the minus version. The plus version is going to be 2 plus 6 over 2. 2 plus 6 is 8. That's 8 over 2, which is 4. We got to do the minus version. 2 minus 6 over 2. That's negative 4 over 2, which is negative 2. Isn't that what we got when we factored it? But like we solved it in factoring in like 10 seconds, and it took us forever to do it this way. Right? And those are our answers. Let's do another one. Okay. X equals negative b. Negative b plus or minus radical b squared minus 4ac. I get no backup music here. All over 2a. All right, so what's a? What's a? 1. What's b? And c? Negative 5. Put it in our formula. X equals negative b. That's the opposite of b. b is negative 4, so it's going to be positive 4. Plus or minus the square root. You can do this in your head. What is negative 4 squared? 16. Minus 4ac all over 2a. So we have 16 minus 4 and minus 5. The minuses are going to cancel out, so it's going to be plus 4 times 1 times 5 is 20 all over 2. 16 plus 20 is 36 over 2. Square root of 36 is 6. We got to do the plus and the minus. So 4 plus 6 is 10 over 2, which is 5. Do the minus. 4 minus 6 is negative 2 over 2, which is negative 1. Yep. Good question. Haley said, "Will those two answers always work? Are we going to have any extraneous solutions?" No, you won't. We're going to have 2 answers, yes, because we have an x squared, so there's got to be 2 answers. And we've got our 2 answers. Okay. So we're good. Number 5. Number 5, do number 5 on your own. Can you do it? Yes. Is it equal to 0 right now? So you have to do that first. So scooch over that 15. All right. Always reduce your fractions. So we got 12/8, which reduced to 3/2, and we got -28, which reduced to -5/2. Right? Everybody? I'm walking around. It looks like everybody's got them, so that's a good sign. So here's a pet peeve of mine. These are both x's. X equals these things, right? So can you write it as a point with parentheses around them? No, they're both x's, right? There's no y. Okay, you can't write it as a point. So don't do it. You can write x equals, and you can put both of those numbers with a comma in between. That's fine. You can just circle both of them like I did there. That's fine too. Both of those are your answers. Okay? All right. Next. This one. Go ahead and start this one. Work it out. Now, mathematicians like as exact answers as possible, yes? Right? So in essence, we would have to actually just simplify this and leave it as is, right? Square root of 61, does that reduce at all? No. So this is our exact answer. Okay, that's our exact answer. Square root of 61 does not reduce. The fraction does not reduce. That is it. However, There are times when we can use decimals, yes? If there's decimals in the problem, in the original problem, or if we're dealing with a story problem. You wouldn't want anybody to say, it took 1 plus or minus the square root of 61 over 10 seconds for the ball to drop. Okay, that doesn't make sense. Okay, so in applications, yeah, we want to know, something that makes sense to us. So how do we put this in our calculators to get our rounded or estimated answers? Let's use our calculators. Everybody got them out? Now, I'm going to teach you something here that will help. Okay, what we're going to do is we're going to put the numerator in parentheses. Okay, however, on some of your calculators, not all of them, but some of them, if you put your square root and you automatically get a parenthesis there, okay, if that is your calculator and it gives you a parenthesis, you're going to have to actually end it with 2 parentheses because you have to close the 61 and then you'll have to close the numerator. Okay? And then you can do divide by 10. You can do all this in the same line, okay, on your calculator. Okay? So, parenthesis, 1 plus, we're going to just do the plus first. So 1 plus square root. If your square root automatically gives you a parenthesis, that's fine. 61. If your calculator gave you the parenthesis for underneath the radical, then you'll need another parenthesis and then another. If your calculator is one of those that makes fractions actually look like fractions and so forth, then you'll just arrow out of the radical and put a parenthesis. Then divide by 10. And you should get 0.88. If you did not get that, let me know so I can look. You didn't end this parenthesis. So you ended the 61, but you didn't end that one. So end that one and then divide by 10. Okay, now, here's a trick. Look at this. Don't type all that back in your calculator again. We got to do that exact same thing. We got to turn that plus into a minus, yes? All right, so push the second button, the blue button, and then push the enter button. This is going to retype what you just typed in your calculator. You see that? Now just backtrack, arrow over to that plus, and make it a minus. And then press enter again. And you get negative 0.68. See what I did there? You could do and once you get 61 in a radical, you could do 1 plus square root of 61, press enter, then divide by 10, and it would give you the 0.88. Then you'd have to type it all again. 1 minus the square root of 61, press enter, divide by 10. That's fine too. Or you can put it all in one if you know how to work your calculator. Okay? Did everybody get those? Let's do one more. Just put this in your calculator is all I want you to do. Let's do 3 plus or minus square root of, 21 over 5. My thing's acting up. Did you get that? 1.52 and negative 0.32. If not, let me know so I can look and see what you're doing. You can't do that. Oh, that's no. What do you mean? What are you doing? That's fine. Do that. Let me see you put that in there. Arrow out. Down. Yep. There you go. Is that what you were doing wrong? Okay. Yes. You did not put the numerator in parentheses. So it's dividing this and getting that answer. Right? You have to put the numerator in parentheses. Anybody else? Questions? Calculator issues? No. Okay. Yes? That is weird. Oh, okay. Yep. There's negative.
Why didn't I do it first time?
I have no idea. That is really weird. I have no idea. All right. Now, last chapter, the chapter before this one, we talked about how to reduce radicals in these fractions like this. And you actually had some of these on your test even. And we did horrible on them. We did. And I'll tell you, my Algebra 2 kids will get everything right on the quadratic formula, and they get to here and they'll screw it up. And they'll miss it every time because they don't know how to reduce this. So watch carefully and learn and do it right so I don't have to mark these wrong. Okay, so square root of 24, does that reduce? Yes. That's 2 and 12, which is 2 and 6, which is 2 and 3, yes? Got a pair of 2s, so a 2 comes out and a 2 dies. So you have 2 plus or minus 2 square roots of 3 over 2. Now, oh yes. That's not why they miss it. Okay, so now, we look at the numbers that are not under the radical. There's 3 of them. One here, and one here. Can all 3 of those numbers, can the same number go into all 3 of those numbers? Evenly, yes. 2, right? 2 goes into 2 how many times? Once. It doesn't go away. 2 divided by 2 is 1, right? 2 divided by 2 is 1, so we just get this 1 square root of 6, or just square root of 6. 2 goes into 2 once. Do I need to put over 1? No, I don't. There's my answer right there. You do not reduce the number underneath the radical. You cannot mix the people outside of the radical with the people inside radicals. You can't do that. So we're not going to turn this into a 3 or something silly like that. Okay? Let's look at number 8. Square root of 72. I know that's 9 and 8. I know 9 is 3 and 3. And I know 8 is 2, 2, and 2. So a 3 comes out and a 3 dies. A 2 comes out and a 2 dies. So this is 3 plus or minus. 6 comes out and there's a 2 left on the inside over 9. Again, we are looking at the numbers. This one, and this one. A number has to go into all 3 of those numbers evenly in order for us to reduce this fraction. Is there a number that goes into 3, 6, and 9? 3. 3 goes into 3 once. That means put a 1. You do not just ignore it. 3 goes into 3 once. 3 goes into 6 twice. And 3 goes into 9 3 times. There is your reduced fraction. Try number 9 on your own. Don't break it. Looks good. Looks good. All right, I'm going to throw a curveball at you now. This one's not on your paper. Just kind of in the margin somewhere. Reduce if you can. Let's see. Now I'm going to do a third one. All right, so this first one, did it reduce? Somebody on the quiz that you're going to have over this stuff next week, somebody in this room is going to do this. And then I'm going to wad up your paper and throw it away. Okay? You can't do that. You can't just reduce part of it. This 5, if there is not a number that goes into all 3 of those evenly, it cannot be reduced. It stays as is. Got it? Number 2. Nobody in here just got rid of those 6s, no? Good. Good. So, how about the 6s? 6, what goes into all 3? 3. 3 goes into 6 twice. 3 goes into 3 once. 3 goes into 6 twice. There's my answer. Now, here's another thing people do. I'm telling you what people do so that you do not do this, okay? People go, oh, 6 goes into this one. Oh, but 3 goes into this one. And 6 goes into this one. No. You have to, all 3 have to be reduced by the same thing. It's kind of like you're putting a 6 under this term and a 6 under this term. Got it? All right. And then this last one, again, something you're never going to do is just reduce the first and go 6 plus or minus 8 square root of 2. You're not going to do that, right? Because that is wrong. You have to be able to reduce all 3. So what goes into all 3? 2. So it's going to be 6 plus or minus 4 square roots of 2 is my answer. Not anything funky. Yes? If you split this one up, you would get 1 plus or minus 5/4 square root of 2. That is correct. However, if it all can't be reduced, all your math books and everything will just leave it like this. They won't break it up into 2. Good question. If all 3 don't go into the same thing, you can't, yeah, and like even this one, if you broke it up, you could say that is, maybe if I can think, you could say, it would say 1 plus or minus 1/2 square root of 2, and that's correct. However, if all 3 do not reduce, then you don't break them up, because it makes it then more complicated than if it was all together. So, all right, so now, because we're all mathematicians and we like exact answers, we're going to leave everything in radical form. We know that radical form means they're decimals, and we can find those decimal answers, but we're going to leave it all in radical form. So, if we're going to look at number 10, we need to move the stuff over yonder. So x squared is going to be plus 6x minus 3 equals 0. This does not factor. I can't factor this. If you can't factor it, the only way we can solve a quadratic equation that cannot be factored is either by square roots or the quadratic formula. Can I just do square roots on this one? No, because it has this middle term, this x term. We can't do that. So we have to use the quadratic formula. A is 1, B is 6, C is negative 3. So x equals negative b plus or minus radical b squared minus 4ac. Background. All over to A. Let's tidy up a little bit, especially underneath that radical there. So I got 36. Minus and a minus is going to make it a plus. 4 times 1 times 3, that's going to be 12. All over 2. So negative 6 plus or minus, that's going to be 48 over 2. All right, square root of 48 is not pretty. So I can't just work it out and get 2 integer answers. It's not going to happen. So I need to reduce this. So square root of 48 is 8 times 6. I know 6 is 2 and 3. I know 8 is 2, 2 and 2. 2 comes out, 2 dies. 2 comes out, 2 dies. So I have x equals negative 6 plus or minus 4 square root of 3 over 2. Now we have to decide if we can reduce this fraction. So we look at the numbers. We got negative 6, we have 4, and we have 2. Is there a number that goes into all 3 of those numbers evenly? 2. So we have negative 3 plus or minus 2 square root of 3 over 1. Do I need to put over 1? No. There's my answers. I'm going to walk you through number 11, then you're going to do number 12 on your own. Number 11, we're going to subtract the 4. 16x squared minus 6x is going to be minus 4 equals 0. Now on this one, let me show you something, guys. Those of you working ahead, shame on you. You'll get the same answer. But let me show you something. Can I factor this? Can I take a 2 out? I get 8x squared minus 3x minus 2. Now set my factors equal to 0 because I can't factor this anymore. So if I set this, can 2 ever equal 0? We ignore that one. Could this one ever equal 0? Well, it can, and how many answers? 2. I can use the quadratic formula on this instead of this one to get my answers. Okay. Does that make sense? The numbers are smaller. I like it that the numbers are smaller. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Minus and a minus make a plus again. And we got plus 64 over 16. Add the 9. I get 73. Square root of 73 reduce. Can I simplify square root of 73? No. Can I just go ahead and like reduce 3/16? No. What if it was 2/16? Can I just reduce 2/16? No. No. So this is my answer. Having said that, let me show you something here. If we had 3 plus or minus the square root of 73 over, let's say, 3. Can I get rid of those 3's? No, because there is a 1 here, and you got to look at all 3 numbers. 3, 1, 3. The only number that goes into all 3 of those is 1. Does 1 do you anything? No. Okay. All right. Number 12. It's all you. Ah. Aha. Aha. If we subtract that, we get plus 4x equals 0. We're going to use the quadratic formula on this. I know you can factor this one, but let's, for fun, do the quadratic formula, okay? Yes, you can factor out a 4x, and then you can get your answers, right? We can do that, but let's use the formula anyway. What's A? 4. What's B? What is C? 0. There isn't a C. What did I do wrong? Yes. I knew I did something wrong. I just couldn't find it. Okay. Now, this number underneath the radical, the radicand, that number is also called the discriminant when we're dealing with this formula. This is called the discriminant. If the discriminant is positive, how many answers are we going to have? 2, right? If this discriminant is 0, if it's 0, we're going to have what we call a double root. Because 5 plus 0 over 5 is 1, right? 5 minus 0 over 5 is still 1, right? You get 1 both times. You only have to write it once, so you say x equals 1. That's true. But since you do get it twice, it's called a double root. Okay? If this number underneath is negative, if this discriminant, this number here, the discriminant, is negative, can you take the square root of a negative number? No. So for today's purposes, it would be no real solution. However, not tomorrow, but the next day, we will deal with that negative because it's an imaginary solution. And there are two solutions, but they're in the imaginary world. And we'll show you how to find those, okay? So I just wanted to throw that. I think most all of your homework tonight all have answers. But if you come across one that doesn't, your book in this section, your book will say no real solutions. Okay? In the chapter next to it, we'll actually find those solutions. They're not real, but we'll find them. Okay? Okay. I've got a video clip to share with you. And you do have homework. So, wait a minute. And we don't have time